Hi, welcome to A Modern Approach to Classifying Medieval Latin Scripts. We'll be talking about computer vision and its utility in analyzing and classifying historical texts. I'm Rafia Mirza,
And I'm Rob Lane.
and we will be talking about, our data set is the CLaMM classification of Latin medieval manuscripts that was put together for a competition in 2016 and 2017. It is about 1,000 images of Latin scripts from handwritten books dated 500 CE to 1600 CE. They divided each year into training and testing sets, and we combine them. So for the purpose of this data set, we didn't really run into any ethical issues given that these were all texts that are well into the public domain. Everyone who wrote them is deceased. And they were assembled and released for researchers, historians, paleographers to work on classification. And so what we wanted to see was how to best to use neural networks for historical document script classification in this specific interest. And the reason that they had this competition is because in the field of paleography, which is historians, medievalists, other scholars who study ancient historical documents and not only some of them translate them, but also even just classifying them is a work that requires for a person to have a great deal of expertise. And so for this competition, they wanted to see if there was a way to use machine learning um, to classify them uh, for paleography.
So, as you've learned in the process of learning statistics, anytime you deal with a data set, it's really important to take a look at your data and try to understand it. That's what this was right here. We're just taking a look and seeing what kind of script samples we're dealing with, and a lot of times the labels of each script type kind of just tells you that they're related. For example, on the bottom row, you can see several in the textualis family. In fact, I'm going to highlight it right here. And we can see that some of these families are related based on their label. We can't just go and assume that just because it's labeled that way, but for brevity, that will do for this point. We'll touch on this later when we get to the confusion matrix. Uh, some of these scripts are notably much harder for me to read than others. That's normal. Script titles change over time, and like Rafia mentioned, these scripts were written over a period of nearly 1,000 years. This shows you more of a complete image of what the input scripts end up looking like. These are all grayscale in here. That's pretty normal for text, especially for this data set. A lot of them are grayscale, but there are some color images. So you can see what happens sometimes when you have a page that has yellowed and become duller over time, or ink that has faded over many centuries of time. These are all things that have to be taken care of during the pre-processing step. So this is what some of that pre-processing ends up looking like. And you can see the original crop sample here, which is just a cropped sample taken from the whole image. That is kind of dirty. We can still see most of the shape, but we made an attempt to not only clean it, but to make geometric transformations for data augmentation purposes, in hopes of helping this model to generalize better over time. One of the more fun pieces of this was the bilateral filter. There was a paper written in 1998 about this, and it uses a sort of a Gaussian filter that reduces noise except at the edges of very different things. So you can see the edges of the letters are kept pretty crisp, but the noise between them is effectively removed. So that was a little bit helpful.
And so when we were looking at what models to use for classification, we looked at CNNs functionally because the way that uh, handwriting works is that it's not standardized in the way modern TypeScript is. There's a lot of variance in the way that the person wrote it, the tools that they used. And so um, since CNNs worked out really well for distinguishing and categorizing script types based on what they look like. And so learning from each image and applying that to the model so they can learn from the script, and they're great at pattern recognition. And so in the field of digital paleography, you can see people are using a lot of different kinds of CNN methods. We'll go into the specific ways that we tried, but it is very useful for these documents with their variants.
There are many neural networks to choose from. And unlike some machine learning models, which have a lot of hyperparameters, in general, a neural network, the layers themselves are the hyperparameters, aside from adjusting what kinds of layers are on the input and output layers. The good thing is that they can be pre-trained. So you don't necessarily have to train every layer of someone's neural network. We primarily used ResNet 50, but we also tried ConvNext, ResNext, which is a combination of those two, and EfficientNet. And we didn't see a huge difference in the performance of these models. There are a few small differences in places that they get confused. And one point for future work that we have laid out is that there is a potential to have an ensemble method that combines multiple models together into one in hopes that you can refine and get a slightly better score at the end. Our top 3 accuracy was 93%. One thing that we learned was that sometimes the way the model performs depends upon how you measure it. Now, if you look at the classification report, you will notice that there are some classes where it does get pretty good accuracy, good recall, good F1 score, but the overall accuracy on this for whether or not the model got the exact right answer was about 73%. 93% of the time, the correct answer is in the top 3 predictions of the model. And as we've shown before, because of the similarity between these different script types, we would expect to see some level of confusion between them. For example, we can look at the cursiva and humanistic family, and there's not a lot of confusion here. Next would be the uncial family, hybrida, and semitextualis. Now, this one is the largest family in general. You can see there is a bit of a class prevalence, but the model seemed to be a little bit more confused between these types in general. But when you put all of those families together, you do see that there is a pattern of certain predictions falling outside of the families, which is something we were hoping not to see, but this is just what data does to you sometimes.
We found that the models that we used worked really well. We tried ResNet, EfficientNet, ConvNext, and then basically 4 CNNs found roughly similar findings. What researchers in the field, and what we think would be interesting for future options would be to try and focus more on the pre-processing to highlight those variances within the families for the models. And then here are some resources on CLaMM and HDR. Here are some selected citations, the complete citations in our paper. Thank you. Any questions? Yes.